This tutorial is to cover topic 4.6, the base strength of amines. First of all, we're going to look at ammonia, which you should remember is a weak base, but also you should remember the definition of a base, which is a proton acceptor. By looking at the ammonia molecule, you'll remember that the nitrogen has a lone pair of electrons. Therefore, it acts as a base because of that attraction between the proton and the lone pair of electrons. If we look at the difference now then between methylamine and ammonia, the only difference being this alkyl group attached to the nitrogen. You should remember that alkyl groups have a tendency to push electrons away from themselves, and therefore these electrons in this bond will be closer to the nitrogen ion. This makes the nitrogen ion more negative and helps the lone pair to pick up a H+ or a proton. This means that methylamine is a stronger base than ammonia. However, there's also another thing to consider, and that is the stability of the ions that have been formed. The difference in these two being that the positive charge now on the nitrogen with ammonia, on the ammonium ion, stays within that nitrogen. However, in this molecule we can see that the positive charge is spread around the ion by the electron pushing effect of the methyl group. The more you can spread charge around, the more stable an ion becomes. Remember that you've got a more electronegative nitrogen compared to carbon, and therefore you have a positive and a negative dipole. If we look at another amine, okay, again we've got an alkyl group. This time it's a C2H5 alkyl group. Again, we're looking at the tendency for this alkyl group to push electrons towards that nitrogen. This has more of an effect than the CH3 or the methyl group, and therefore is a stronger base than methylamine. So ethylamine is a stronger base than methylamine. The last strength we're going to look at is for phenylamine. Now you need to remember about the delocalization stability of our benzene ring. You'll remember that you have a delocalized ring of electrons above and below the plane of the carbon atoms. But remember this all-important lone pair of electrons. This lone pair of electrons will actually overlap with the delocalized ring of electrons above and below. This means that the lone pair is no longer fully available to combine with hydrogen ions. The nitrogen is still the most electronegative atom in the molecule, and so the delocalized electrons will still be attracted towards it. But the intensity of charge around the nitrogen molecule is nothing like it would be in ammonia, and therefore phenylamine would be a weaker base than ammonia. So this will be the weakest base, followed by ammonia, followed by methylamine, followed by ethylamine.